I'm now going to do a bunch more examples using the chain rule. So let's see. Once again, if I had f of x is equal to, let's say, actually I don't like this tool that I'm using now. Let's say I want to use this. F of x is equal to, let's say, x to the third plus 2x squared minus, let's say, minus x to the negative 2. We haven't put any negative exponents in yet, but I think you'll see that the same patterns apply. And all of that to, let's say, the minus 7. We want to figure out what f prime of x, or the derivative of f of x is. So this might seem very complicated and daunting to you, and obviously to take this entire polynomial to the negative 7th power would take you forever. But using the chain rule, we can do it quite quickly. So the first thing we want to do is we want to take the derivative of the inner function, I guess we could call it. We want to take the derivative of this. And what's the derivative of x to the third plus 2x squared minus x to the negative 2? Well, we know how to do that. That was the first type of derivatives we learned how to do. It's 3x squared, and then 2 times 2 plus 4x to the first, or just 4x. And then here, with the negative derivative, we do the exact, a negative exponent, we do the exact same thing. We say negative 2 times the negative 1, right? There's a 1 here. We don't write it down. So negative 2 times negative 1 is plus 2 x to the, and then we decrease the exponent by 1, so it's x to the negative 3. Right? So we figured out what the derivative of the inside is, and then we just multiply that whole thing, times the derivative of kind of the entire expression. So then that'll be, we take the minus 7. Let me do a different color. So this is the entire thing. So then we take minus 7. So it's times minus 7. This whole expression, I'm going to run out of space. X to the third plus 2x squared minus x to the minus 2. That's minus x to the minus 2. And all of that, we just decrease this exponent by 1 to the minus 8. So let me write it all down a little bit neater now. So we get f prime of x, or the derivative of f of x, is equal to 3x squared plus 4x plus 2x to the minus third power. I don't know why I did that. That's minus 3 times minus 7 times x to the third plus 2x squared minus x to the minus 2, all of that to the negative 8 power. And we could simplify it a little bit. Maybe we could just multiply this minus 7 times, we could distribute it across this expression. So we'd say that equals minus 7, so that equals minus 21x squared minus 28x minus 14x to the negative 3. All of that times x to the third plus 2x squared minus x to the minus 2 to the minus 8. So there we did it. We took this, what I would say is a very complicated function, and using the chain rule and just some of the basic rules we had introduced a couple of presentations ago, we were able to find the derivative of it. And now if we wanted to, for whatever application, we could find the slope of this function at any point, x, by just substituting that point into this equation, and we'll get the slope at that point. So let me do a slightly harder one to show you that the chain rule, you can kind of go arbitrarily deep in the chain rule. And once again, I don't know, image, let me see if I cleared the image, invert. Oh, that was pretty fast. Look at that. Okay, so let's say I had, let me see if I can write it a little bit thinner. Let's say if I had f of x, I don't know if you can see that, so I'm going to do it a little fatter. F of x is equal to, I'm going to make it a little bit more complicated this time, 3x to the minus 2 plus 5x to the third minus 7x, all of that to the fifth, and then this whole expression to the third power. So you're saying, Sal, you're starting to go nuts. This is going to take us forever. Well, I'll show you using the chain rule. It will not take that long. So the way I think about it, so let's see, f prime of x equals. I start off kind of with the innermost function. So let me see if I can use colors to make it a little bit simpler. So let's take the derivative of this innermost function first, right? I mean, let me give you the big picture. We want to find the derivative of the innermost function, and then a little bit bigger, and then a little bit more big than that. I know that's not precise mathematical terms, but you'll get the point when I show you this example. So first we'll do this inner function, this inner expression, and the derivative of that's pretty easy, right? It's 15x squared minus 7, right? That was pretty straightforward. And now we're going to want to multiply that times this entire derivative here. So let me circle that in a different. So then we want to do this. We're going to multiply that times this entire derivative. Well, that's just times 5, and we just pretend like this is just like pretend like this was just an x here, right? Because the derivative of x to the fifth is 5x to the fourth, right? But instead of an x, we have this whole expression, 5x to the third minus 7x. So we'll write that. 5x to the third minus 7x. And now the exponent here goes down by 1. So it's 5 times 5x to the third minus 7x, all of that to the fourth power. So we figured out the derivative of this so far. And then we want to figure out the derivative of this. So we'll add it, right? Because we're trying to figure out the derivative of this entire expression. So this is an easy one. Let me draw that in a different color. So then we want the derivative of this. So that's negative 2 times 3. So that's negative 6 x to the minus 3. So what have we done so far? We've so far figured out the derivative of this entire expression, right? The derivative of that entire expression using the chain rule is this. And now we're almost done. We just have to multiply that. So I've run out of space on that line, but let's just assume that the line continues. So that's times, and now we just take the derivative of kind of this whole big thing. And now it's going to be the derivative of I'm going to use this brown color. So it's a whole big expression to the third power, right? So that becomes times 3 times the whole expression, right? That's this 3 times, now I'm going to write the whole thing, 3x to the minus 2 plus 5x to the third minus 7x, that to the fifth, and then you decrement this by 1 to the second power. That was an ultra confusing example, and this is probably the hardest chain rule problem you'll see in a lot of the questions you'll have on your test. But you see, it wasn't that difficult. We just kind of went to the smallest possible function, and actually the smallest possible function would have been one of these terms, but we just found the derivative of this, which was 15x squared minus 7. And then we just use the principle that the derivative of kind of a function is just the derivative of each of its parts. So, the derivative of we figured out the derivative of this inner piece, which was 15x squared minus 7, and then we multiply it times the derivative of this slightly larger piece, which is 5 times this entire expression to the fourth. Then we added it to the derivative of 3x to the minus 2. And then that whole thing, and actually I should put a big parentheses around here, that whole thing, we multiply it times the derivative of this larger expression. I think I might have confused you, so I apologize if I have. And in the next presentation, I'm going to just do a bunch more of chain rule problems, and at some point, it should start to make sense to you. I think it's just a matter of seeing example after example after example. I'll see you into the next presentation, and I apologize if I have confused you.